you're going to turn your research into the publication, then how you going to turn your publication into the thesis? Very simple, very easy. Very simple, very easy. Oh, you want to know or not? This thing. Yeah, very simple. Very simple and very easy, you know. Which one? This one can be read or not, but this one is for whiteboard or not whiteboard. Okay, you see, no matter you are the master study and or PhD study, the difference is what? The depth of your the study, right? The depth of study. In your master study or PhD study, you might have how many objectives? Maybe objective 1, objective. Three. Some have 4 objectives, correct or not? 1 or 2 or 3, 2 or 3 objectives. Very simple. If you have 4 objectives, let's say 4 objectives, these 2 objectives, you conduct the experiment or whatever. You come up with 1 paper. And 2 paper. Then how you convert in this paper into the thesis? For our engineering, the thesis is very simple, very easy. Standard format. Very, very standard format. What standard format? First one is what? Instruction. Instruction, you have what? Your objective, your problem statement. Problem statement, the objective, correct or not? Your objective. Then second. What is the second chapter? Research review. Correct or not? You have to conduct your research. Third chapter. Methodology. 4. Sometimes your 4 is a result and discussion. Some you divide into a chapter 4 and chapter 5. Result discussion, correct or not? So I make it 1 chapter. 1 is conclusion. Correct or not? Reference. Correct or not? So you see, many of the students, they tend to complete everything first, you know. Complete all the experiment, then start writing. Then at the end of your study, cannot come out anything. You forgot what you conduct already. So don't know how to start the writing. Because too much already. The one thesis needs 100 pages. To PhD maybe 150 pages. So don't know how to start. So don't write at the end. You write after you conduct part of your experiment. You record down first. Record down not necessarily to turn into the paper. Record down, it means you turn your result, the data. You turn into data into the paper or figure. Don't let your data in the raw data yet. Turn into the tables and figures. Turn into the table and figure first. Then start to write up the fittings. Then after that, you come up with 1 paper. Then second paper, if let's say, or each objective. If you are the PhD student, your objective is you study more in depth, correct or not? Each objective can be write 1 paper, or 2 objectives. First 2 objectives 1 paper, then third objective another paper, fourth objective another paper. Then after that, if you have this thing already, turn your thesis. Very simple. Within 1 or 2 months, you can make it. Objective from here. From paper 1, objective right here. Four objective from here. Then your methodology. Methodology section 3.1 overall. You need to connect everything overall. You write overall. Then 3.2. 3.2 is what? You match back with your objective. 3.2 is what? The method that you conduct. Method is a much more easier part that you can write, you know. 3.2 is whatever that you conduct. 3.2 is what? Method with the objective number 1. From where? On this paper. Then we have the 3.3, 3.4 or 3.5. But the only thing that you need to do is what? How to make it connect. Like a story, right? Then from here, you see, from paper, from here. have already. Then result and discussion. Result and discussion. So 4.1 overview. What you need to write for your thesis. Then 4.2, 4.3, 4.4, and 4.5. From where? From here. From here. This is what I teach my students. Then conclusion. Conclusion. 4 objectives. One is the instructions paragraph. Instruction paragraph. Then 4 objectives. We write 4 paragraphs. From that. From here. Then the only thing that you need to do is connect that. That's it. Your thesis come out. Simple enough. Simple enough. So once you conduct the experiment, table up your raw data, your raw data into the tables or proper figure. Then start analysis. See what type of analysis. Make the comparisons. Of course, before you start, you need to do what? Digital study. Digital study to figure out what? Do the digital study to figure out the gap. What is the problem statement and what is the gap? That is a thing. That's another thing. Do the digital study. So digital study also you do from time to time, not until the very end already. You already conduct anything. Then every digital review is no longer new for you. You have no interest to write. Correct or not? You are lose interest. Oh, I need to write this one. I already know. This one I already know already. Then you write record down from time to time. That's the thing. This is the thing. This is how we turn the research into the papers. Then from papers turn into your thesis. Then at the same time, do your digital study, detailed research study, update your digital study from time to time. From here, you figure out the problem statement and also the significance or the novelty of your study. Novelty, then I stress again the novelty. So novelty is not if you are able to create something new, it's good. It's very good. The novelty and the significance is what is the improvement of your study. The improvement, every improvement are counted. Every improvements are counted. Yeah. What any innovative idea, innovative improvement are counted. So what is the improvement compared to field study? Field study means what? You do your benchmarking study, do the digital study. Oh, they want to conduct this thing, but I have an idea. So how to design my process? Design my thing. That's the improvement. I'll see what is the improvement after you conduct experiment compared to your benchmarking study. Yeah, that's the thing. So any questions so far?
Regarding this esterification process, are there any other side products taking place there? You said here, generally when you speak about the esterification efficiency, in certain slides, although esterification efficiency is high, that and paying yield is...
Which one? You go to a slide. This slide.
This one more guys. Like here, esterification efficiency, the second bar is dramatically reasonably increasing, but permanent is other side products also something of this?
This one increasing. What is your question? I can't understand your question. Sorry.
No, so I was just wondering, other than our side product, are there any other side products?
Oh, side product. Yes, they are. They are. But I didn't record down. Yeah, I didn't report here. They are. Water, other impurities. Yes, they are. Water. Gasoline also. Yes. Yes, they are. In the thesis and in the paper, we discussed the glyceride. How we separate the water and glyceride. We do separate. Have to separate. If not, cannot get the high purity of the fatty acid mediator. Then also sometimes we do the washing also, because this is in the industry they are not ready to do the washing. They just do the separation only. The washing, because experiment, because we are conducting research, we want to see after we do the washing whether we can wash out the impurity or not. And after that, there are still many things can do. After wash up, we can analyze what is the impurity that we wash out. If it's one, we really need to investigate in that. What is the impurity inside there? Then from there, maybe we can redesign the process so that the impurity cannot not appear in the because this one this study we focusing more on because the production side. For my group, we do the combustion side also, you know. But I didn't show anything about the combustion side here because the background of the people here is totally different. We do, but I can briefly share with you. The NOx emissions will increase. No matter what is the biodiesel we are using, increase. But the percentage is not high, but increase. The NOx emission increase. We do on the engine combustions. We do the combustion test. Increase. The NOx increase, but other emissions reduce. Yes, not increase. Yes. NOx increase, NOx increase, NO increase, and N2O also increase. Yeah, it's increased. It's increased, that one. We do have other study on that, but it didn't, this time I didn't show anything on that. Yes, it's increased, not increased. So, oh, N2O, O. No, it's nitric oxide, nitro oxide or something like this. Yeah. Nitric oxide. Yep. Yeah. Any other questions? Oh, yeah. Just now I mentioned the test method. So for every experiment, if for those are the PhD or master scholar, for your every methodology or every method, you need to know what is the standard test method you are using. Then people ask, what is your repeatability? The test method. Every testing, they have the standard test method. You know, what is the test method you are following? Why? Because if not, first time experiment, you follow this test method on your own way. You design your own test method. Don't know what is the test method you are doing. Then the second test, you using the second test method. The third one, cannot be consistent. Must have a very consistent test method. No matter what is the test method you are using, as long as you are able to justify. Yeah, must be able to justify. So this is the test method we are following for the certain experiment. Each experiment we have the certain test method, standard test method. Yeah, that's the thing. See what else I can show you. This is the study. So you see, every time before you start the study, we also determine the composition, the element analysis and also the participant analysis. Yeah, CH, CSN, and O, and content. This is another effect which I didn't show you in the main slide. Element analysis, you see, the NOx, nitrogen, the element we have. Normally it's less than 10%. We found it less than 10%. Still have. Yeah, that's the thing. We still have much more result here. I just show you some result. So any other questions? Yes.
So we have solid fuel, we have liquid fuel. There is marine fuel as well. Bio oil is very used.
Marine fuel. Yeah. I didn't study on the particular study on marine fuel. Yes.
They have a lot of different standards as well.
Yes, correct.
Right, but it's not as strict as diesel.
Yes, different.
Right, lower than diesel.
Lower than diesel. Yes,
Yeah,
lower than diesel.
Lower than diesel.
Yes.
And they also have their own standards.
Yes, correct.
They have huge demand.
Okay. Okay.
They have huge demand, like millions of tons.
Yes.
When they buy in millions of tons like that. There's a very good market.
Yes, correct. True. And also, not only that, there are a lot of the industry use in their generator as well. You see construction, they are on site. They don't have any electricity during the construction. They use the generator themselves. That one also using a lot of diesel as well. Yes, normally, so that's why the biodiesel is very safe because the fresh point is very, very high. Normally, fresh point for the biodiesel is very high. Fresh point. fresh point is different with the ignition point, you know. Init point. The init point for the biodiesel is not very high. It's easily burn, but the init point for the bio oil is very high. Sometimes it's very hard to burn, you know. Sometimes it's very hard to burn. The init point and the fresh point is two different things. Two different things. So any other, yes?
Can we say ultrasound treatment is better than hydrothermal treatment, and if yes, then how?
Okay. No, I didn't say the hydrothermal is better than the ultrasound is better than the hydrothermal. What I want to introduce is the compared to the traditional process, how we embedded the one technology. For example, using the ultrasound in the front esterification process. Yeah, that's the thing. I didn't mention that the ultrasound is better than the hydrothermal because our target product is different. Target product for the hydrothermal is different. Yeah, hydrothermal can get maybe the green diesel or whatever. Maybe for their feedstock is different. Their process is different. Yes.
What if we talk in terms of extraction efficiency? Then what if we compare these methods and in those terms in extraction efficiency?
You mean the extraction efficiency? What is your question?
If we compare the extraction efficiency of hydrothermal and ultrasound.
For the hydrothermal is you need to make sure what is the target product of your hydrothermal. For example, for me normally I use the hydrothermal to do the treatment only. I didn't focus on certain product yet. You know, do the treatment. Treatment I mean treat the waste. Treat the waste only. For hydrothermal normally I used to treat the waste. Then treat the waste. Then we use the very typical process. Then see what is the product that we put it first. Then we focus on the product. See whether the product can be turned into something valuable or not. This is what we are doing. So our is first thing do the treatment. Then after that from there we see what is the value added product can be produced. Then we focus on to convert that value added product into something useful. And to close the loop. Close your loop. I mean, do the treatment as well. Then we have some product to produce. The byproduct can be produced. Yeah, that's the thing. Then for this process, we purposely design so that what it can produce the high biodiesel yield and pure biodiesel yield. Yeah. For other later on, I mean maybe tomorrow I show you what is the hydrothermal process. Our hydrothermal process I didn't focus on the certain products. We just see what is product and how we are going to utilize the product. This I will show you. That's the thing. I didn't focus on products. And some we focus. For example, the pyrolysis process. Oh, we focus. We want to produce the bio oil. That one is particular. We focus. Then some is we just want to do the treatment only. Because different process, different things, we cannot compare directly. See what is your needs and demands. Needs and demands depend on needs and demands. So can play around because the master and PhD students just play around with a lot of the experiments. Well, for me, I like the experiment because with the experiment we have a lot of data. Because now the current scholar they like to do the simulation. For me, I also start the simulation, but no matter what simulation I'm doing, I will do the experiment data to verify, to do different. After the simulation data only paid at the fundamental research so that I know this process, this design, this concept is good. And after that, I will go back to the experiment as well. I don't need to do a lot of experiment, the unsuccessful experiment before I conduct the experiment. This is the tool of the simulation. But now I found that many of the researchers and the scholars, they tend to do the simulation. Yeah, because why? Fast. No need to go to the lab. No need to set up the thing. Set up the thing, maybe take design the reactor. Take maybe half year to 1 year, you know. Yeah, that's the thing. Very hard, but worth to invest. For those want to be the researcher or academic staff, it's worth to invest your time on that. You know, they want to pave a very strong foundation for your future careers. if you want to be the academician or researcher. If you just want to get the your master, doesn't matter. You don't need to do. And after that, you want to be the investor or you want to come up with a product, you don't need to go into detail. Yes, but for those are interested to be the academician and to be the researcher, this one is very important. I think that is very important. The curiosity, the interest for you to do product research is very important. I tell you. Yes.
What if we keep the parameters same and our product is same? Then if we compare these methods, then will it be a valid comparison?
Compare what? You compare with the simulation and also the...
No, the previous question that I asked, comparing these two methods or ultrasound, microwave and the hydrothermal process, our product is same, parameters are same, then is it valid to compare?
Valid. Because you want to design with the different process. Yes, this is very same raw materials, totally different process. But your target product is the same, maybe same, or different also doesn't matter. If you have the certain target product, then you can compare with the certain with the process and with the certain target product. If you don't have the certain target product, you can just compare with the few methods. See what is your product that you produce, which one can produce more higher values product. That one also can. It depends on you how you going to justify. So for research, there are nothing wrong and right, but we must have the critical thinking. We need to know what we are doing, what is the justification behind. Not because of my supervisor asked me to do so. My supervisor then during the defense, my supervisor asked me so. I only have this equipment. That is not the very answer. You have to know clearly what is the justification. You do the certain experiment, do the certain thing, certain testing. This one you have to know. That's the thing. Then the other thing you can do on the part A, B, C, doing research like go to the maybe I want to go to that direction, to that way. You can go here, then round there, go here. Nothing wrong and right. Nothing wrong and right, but you know. Then, but your destination is go there. You must always know your destination is go there. Don't lost somewhere else, Yeah, go there. But follow this path. It's up to you. But you must know why you go from this way to that way. What's your justification? Yeah, you have to know. That one you have to know. So any other questions?
So what is the importance of the corrosion strip? Copper strip corrosion.
Oh, copper strip corrosion. Okay, that one. Because previously I mentioned that the biodiesel generally have the higher acid value will cause the wear and tear in the engine component or genset component part, the wear and tear on the part and components. So copper corrosion is to see what is the corrosion level of that fuel. Yes, this is one of the properties that in the EN standard, but this is not a very crucial property. It's one of the properties only. The crucial properties for the biodiesel is what? The acid value, the film content, density, viscosity. Then sometimes oxidation stability, if some oxidation is too low. Then the other is just the supporting parameters. Yeah, supporting parameters. But the acid value, viscosity is very important. The one is very important. Then some also measure the water content, because the water content must be less than certain percentage of the water content. If not, also will cause some wear and tear on the engine part and components. Yep, this one. Because it will cause the corrosion. Why corrosion come from? Acid value. The acid value. The acid value. I have many different study. But I don't know which one is within your interest. So today I also prepare another. Just now I mentioned I want to show you two studies. This one also using the ultrasound. Also for the biodiesel, is using the spent coffee ground because I don't know in India, in Malaysia previously we are not really drink the coffee, but recently for the last 5 years the people drinking coffee is increasing, a lot, a lot of coffee shop, cafe or whatever drinking the coffee. So make me have this idea to have the spent coffee ground, for the for two products. I target two products. One is initially the biodiesel, then secondly is for the biochar, sorry for that, biochar. I have two targets for this study. Main target is the biodiesel. How about India? India also increasing a lot. The last time don't have, right? Increase, right? Previously. A lot of Starbucks and other type of the coffee shop are similar to Starbucks one. Yeah. In Malaysia also same. Recently, this 5 to 10 years I can say. Starting to 10 years back is starting. Then now the last 5 years is a lot increasing. Social media, right? A lot of drinking. So this one is one of the problem in the future also, because why? Some of the that cafe or the cafe they find us, say they have a lot of the this one spent coffee ground. So how we can make it sustainable in line with the SDG? This one we conduct this topic before they find us. They find us. This one is 2015. Then recently, few of the cafe, the chain cafe, the large chain cafe, they start to think how they can utilize this spent coffee ground, but mainly two purpose, two products they can produce. One is to attract up some of the biodiesel or biofuel, to convert into biofuel or biodiesel. Another one is what can be converted is biochar as a biofertilizer to use back in the plantation or agricultural areas. So both I also study today. This one is tomorrow I will show you about the biochar one. Then today is about the biodiesel. The instruction is the same thing. First two generations. Then this one. This is some of the statistics. They are, this one is 2016. 8 million tons of the coffee produced. And produce 65% of the waste residue. 65 out of 8 million tons, 65% is produced. What is the? Oh yeah, you see the coffee. This one is the. Why is it? This one. Oh, I think it's already. Right already. This one should be 42%, 25%, 25%, 80%. I mean, around 42% of the semi-cellulose, then the cellulose is 13%, then 25% of the lignin. Lignins, we talk about the lignins. Lignin is the compound or the component is very hard to degrade. Degradation, yeah, because normally you can easily degrade the cellulose and hemicellulose. So that's why, as I told you, we need to know go back to the parameters of the or characteristics of the biomass. If we know the lignin is very hard to degrade. It needs to degrade at very high temperatures, So normally. So we prefer to find the biomass that has a lot of the cellulose or hemicellulose. More better, yeah. It depends. It depends. Some, if you can able to find one method to degrade the lignin to something useful, that one is also very good. But for our group, yeah, it's not our actions. So we didn't study much more on the lignin. We just leave it, but we know that still something. Not degraded. That one is a lignin. Coffee, smell, yes. These are general compositions. It in these three compounds. These three, I mean what? cellulose, hemicellulose and lignin is available, right? It's available in most of the organic biomass waste. Organic biomass waste, these three. It just depends on the composition, which one is higher, which one is lower. Yeah. Yes, they have. Yeah, I don't know what their lignin percentage, yeah, but they are. That are the three main components. There is the problem statement. Come with the objective. We need to see what is the effects on this. So yeah, that is the in our lab. So that's why we have quite complete facilities for bio the solid product analysis. Solid product analysis. Not only this one, we still have the TGA, GCMS, the GCFID, and we have the viscosities, the bone parameters, stabilities. Yep. Product similar. One thing is different. Coffee grounds. The S normally is low. So through the acid acidification. Moisture they have very high moisture after the coffee ground. This ultrasound. Oh, this one we compare two methods, not we compare two methods. One is solvent and second one is different. What is the difference? So just now I still remember what candidate asked me. So what is different process? We have only in the they tend to use catalyst process because low cost. In industry like low cost, but what is the difficult to don't need to do industry don't care because why low cost. So the wastewater and step that is a drawback. Pro and cons for so as I the way process is what non-catalytic the high pressure, high temperature. You see, it's super fast process with the higher can be convert FFA. There are no any catalyst needed. Then I can easily produce a very pure product with no any waste. But it is due to high temperature, high pressure, and high initial cost. High initial cost. Yeah, that's the thing. That's the thing. Yeah. Then the enzymatic reaction is what? Enzymatic reaction is a totally green process. Not using any chemical. But what? The process are relatively slow with the high cost of the enzyme. So I think I would stop here. So any questions? Before this one I will continue tomorrow. So any questions?